In this video, I'm going to show you how to save hundreds of dollars per month by eliminating subscription services that you pay for in your automations. We'll use AI to build out a nearly free API that we can use to replace all of the paid subscriptions in our automations. I built out some really cool automations in the last couple months, but the biggest complaint was all the monthly subscriptions needed to run these automations, especially in these fully automated faceless video generators that required multiple APIs, image generation, and the ability to merge all of those videos together and overlay audio. So in this video, I'll show you how to write all the code for your own API using AI, where we can deploy our own little server that can do the work of all these paid subscriptions at a fraction of the cost. And you can actually build out your own customized make modules that can interface with your own API. By the way, this is a project that we'll release to the public for free. It's called the No Code Architects Toolkit, and it will help you deploy your own API with various endpoints to eliminate the cost from third-party APIs. And in that roadmap, we plan to release the ability to let you merge videos and overlay audio for automatic faceless video generation, transcribe and translate audio and video without the 25 megabyte whisper limit, automate podcast editing, adding intros, outros, music, etc., automatically adding video subtitles. And we'll be adding a lot more as we go, as we find other APIs that we can bring into this free toolkit. So we'll be able to work together as a group to identify various APIs that we should build into our free toolkit. Really just by looking at our own automations and seeing where we have monthly subscriptions for things that we need to pay for, and then we can build out our own free solutions to eliminate the need for them. In today's video, we are going to create an API that can help us replace OpenAPI's Whisper. This is a module that allows us to convert any video or audio into a transcription, which we can then use in our automations. Now, this module in itself isn't truly that expensive, but there is some limitations which are a constant pain. Number one, we can only transcribe videos or audio files up to 25 megabytes, which is very easy to do, which then requires us to use Cloud Convert, which will make the audio or video file much smaller so that we can use it with OpenAPI's Whisper. And there are some examples where the file is so large that you can't even reduce the size to under 25 megabytes to use with OpenAPI's Whisper. Because not only do you have to pay for two different APIs to make this work, but sometimes the file is so large it just won't work at all. So we'll create and deploy our own API that doesn't have the 25 megabyte limit and doesn't require us to have these two subscriptions to get transcriptions done. So in this example, we're going to use Claude to help us write all of the code that we need to deploy our own API. And it's also going to help us create this Docker file, which is going to make deploying this code very easy. Now, when you think of an API, let's think about OpenAPI and the service that they have that we use a lot. In that, we can call ChatGPT and other services like Whisper in order to get our transcriptions from video. Now, all an API really is a computer somewhere that is listening for requests and has some code that is run every time we make a request. Say we want to make a request to OpenAPI to transcribe an audio or video file. We will send them the audio or video file. They will do some processing within their server, and then they're going to send us back the transcription, which we can then use in our automation. And essentially, because they made this process convenient for you, where you don't have to think about what goes into this little circle here, they're gonna charge you some monthly fee in order to use this service. But what we're gonna do is we're gonna create our own service using this tool called Docker, which is going to help us create that API that we can call from make.com and get a response. Now, all Docker really is a service that allows us to create our own little servers and deploy them very easily, where all of the code that is needed to run our API is within a container, and then we can deploy that container, make calls to it, and get a response. And in order to create one of these Docker containers, you need something called a Docker file, which describes everything that needs to be in your API. Now, building this Docker file used to take a lot of expertise, but now we can simply go to a platform like Claude and we can describe the API that we want. And I'll show you a bit more about how to write this in a minute, but then it will actually generate the Docker file for us. It will generate all of the different services or applications we need within that container. It will also write all of the code to service the requests that come into that container. And it will generate also some supporting files that we need to have in order to make this work as well. So while understanding everything about Docker is a big job and we can't do it all on this video today, we can use AI to generate this Docker file, which will help us build this container with our API that can take in requests from make and respond, all without having to write any of our own code. All we have to know today is how do we write the prompt, and then Claude can write out out all of the different aspects of the project that we need in order to deploy this successfully. And if you'd like access to these prompt templates and all these files to deploy your own API, make sure to jump into the No Code Architects. It's a growing community where you can get support for all of your questions, including live calls, and also a bunch of other templates that you can get direct access to, like you're seeing in this video today. All right, so now before we get into the build, there are a few different tools that you need to have in order to go along with me and build this out. The first one is called Postman. You can go to postman.com/downloads, and then you can download the app for your computer. You can download it for Mac, whether you have an Intel or a Apple-based chip, and then for Windows, you can download a version as well. You will also need the Docker desktop app. You can go to docker.com/products/docker-desktop, and then you'll be able to download that from their webpage. You will also need a text editor where you can copy and paste code that we generate from Claude. You will also need the prompt that will generate the Docker app and all of the different files we need to deploy. And of course, you will also need access to Claude, and we'll be using Claude 3.5 Sonnet. All right, so now let's get started. The first thing we have to do is drop in a prompt into Claude to get it to generate the various files that we need in order to deploy our own API. So I'm going to jump over to Notion where I have that prompt. Now in this prompt, there are going to be words and terms here that you may not be familiar with, and I will try to explain as best as I can, but it will take too long to try to explain every last little new term here. But without knowing those terms, you will be able to execute this prompt and have a working API, and then you can learn what these different terms are along the way. So again, starting at the top in a little bit more detail, we're going to create a Dockerized Flask API that can contain several endpoints. We're only going to deploy with one to start. We need one environment variable that we can set so that we can change the API key for incoming requests. Then we're going to list all of the endpoints. Our initial endpoint is transcribe media. We're declaring the function name that we want Claude to use in the code. And then we just basically describe what's going to happen. This endpoint is going to help us convert media to a transcript. We're going to accept external requests as a post with a JSON content type. It's going to require the X API key in the headers for authentication. We're going to take in one parameter in the JSON body. We are going to accept the media URL. So when we call this API call, we're going to give it a media URL that it can use to download and transcribe. It's going to generate a unique job ID. Then that API is going to download that media file provided from the incoming JSON request. It's going to download that to a temp directory. So you see here, all I'm doing is describing the literal steps to take in order to complete this task in human language. I do know how to write these APIs from scratch if I had to. So I am able to guide the process in a experienced way. Then after we've downloaded that media, we are going to use OpenAI's Whisper to convert the downloaded media file into a transcript. Now, one thing you might notice here is that we are using OpenAPI Whisper to do the conversion. But in this case, what we're going to do is we're going to actually download the free version of OpenAPI and install it and use it locally so that we don't have to use OpenAPI's API to do the same thing. They provide this technology for free, but you have to download it, install it, use it the way we are in order to access it for free. And then if everything was a success, we're going to return the HTTP code 200, which is a success, with a JSON containing the response, which is the transcript. And then if it was a failure, we're going to return the HTTP code 500 with the JSON containing the actual error details. And then there are some other requirements here as well. I'm asking Claude to make sure to use Python 3.9 and the latest stable versions of all of these different libraries. I want it to pre-download the Whisper during the Docker build process. I want it to run Flask on a specific port. I want to increase the worker timeout for this application here to 300 seconds. And I want to use compatible versions of Flask and this other module here. I want to make sure I don't use the .env module because we're using Docker. All endpoints should use the authenticate decorator. Then I'm just describing what happens if the API key doesn't match the supply API key from the user, which is an unauthorized message. Check for and avoid naming conflicts, especially when using decorators, and then use proper error handling. And then I ask it to include these different files, the Docker file, the requirements file, the full Python script for the API, and then these two additional files here. So again, there's going to be a lot of things here that you don't necessarily understand, but you should still be able to build this regardless and even fix any issues that pop up using Claude. And then as your experience goes up, you'll be able to add in in these other clauses here like I've done to reduce further errors when I run this again. But when I ran this the first time, I didn't have any of these different things and it still worked just fine. But I had to go through a few ups and downs in order to resolve a few issues, and that's just why I have these here now. So you'll want to copy this into your own text file so that you can cut and paste it into Claude. That's what I'm going to go do now. Just going to grab everything all the way up to the top. Going to head over to Claude, and I'm simply going to paste that in and run that. Then it's going to create the Docker file, the requirements file, the app code, the Docker ignore file, and the git ignore file. And then finally, it provided a sample of how we're supposed to call that API in order to test it out. And then it also gave us some instructions in order to actually run this Docker file locally so we can test it out. So now what I'm going to do is I'm going to jump into my documents, going to go to documents, going to go into development, and then I'm going to create a new folder. I'll go ahead and call it the Docker transcribe API demo. Then I'm going to go into my text editor here, and I'm going to create a new file, and I'm going to go to the top of the Claude response, and this is the Docker file. So I'm going to go ahead and copy that into the clipboard using the button here. And then I'm just going to paste that into this, and then I'm going to save it. It's going to ask me which folder. I'm going to go to development, then we'll go into our new folder here, the Docker transcribe API demo. We'll save that there. I forgot to update the name. Save as Docker file with a capital D. No extension, save. Now we'll create a new file. This time it's going to be the requirements.txt. I'll copy that into my text editor. I will save, make sure it's in the right directory, the Docker transcribe API demo. In this case, I'm going to call this requirements.txt. We'll save that. Next up, we got the app.py. I'll copy that using this button here. New file, paste. Save. This is going to be app.py. Go ahead and click save. Next up, we've got the Docker ignore file. Again, we'll copy that, create a new file, paste that into here, save. And this one's going to be .docker ignore. Let's make sure I'm spelling that right. Docker ignore. Remember, it's .docker ignore in this case. We will save that. And then we have one more that we need to copy in. This is the git ignore. Again, we'll copy it, go to our text editor. We will save that code. This one is going to be .git ignore. Save. And now we should be able to look at our folder here. This was one of the files that was a mistake. I'll delete that. So again here, remember that we added these two files here, Docker ignore and .git ignore. And when you have that dot before a file name, most operating systems will hide that file from you. So I was actually asking Claude, how do we make sure that those are visible? And it has a command here that I'm going to run from my terminal. And if you've never used the terminal before, you can access it by going to your apps and then going to other. And then you'll find the terminal right here. I'm going to open up mine. I'm going to run that command. And now notice it reloaded my Finder here and I can see those two files here, which is great. Now I know that they're actually there. So now if I jump back to our assignment here and I look at the different files that we needed, we had 5 files that we needed: the Docker file, the requirements.txt, the Python script, the Docker ignore, and the git ignore, and it looks like we have all of those files here. So now to test this locally, there's just a couple of commands that we have to run. Again, remember, you must have installed the Docker desktop app in order to do this. So again, I'm going to jump back to my terminal. I'm going to cd into my documents folder, development, and where I've added the new folder for this project. And I'm simply going to run this one command here. I'm going to rename this to something else just for this video, Docker API build. So you'll want to execute a command just like this, Docker build -t, Docker API build. And since I'm building it on my Mac, I'm using this little tag here, which is :Mac. It's just telling the Docker system that I want to tag this build with Mac because I'm building it on my Mac. We'll go ahead and run this in the terminal. So now what's happening is that it's actually building out our little Docker image. It's building out our little container that has all of the little pieces of code that we need so that we can call it from make and get a response from it. And if you think about it, what's cool is that we didn't have a single error there. So we built out the entire Docker container without an error simply by going to Claude and asking it to generate these pieces of code for us. So now all we need to do is actually run this Docker container. I'm going to change this code here from what it was to match this here. So here in this step, we built the Docker container. In this step here, we are going to run it. And again, I just changed this value here to the same value that I used here when I built the image. And we are also passing the API key test123 to this Docker image. So when it runs, we actually have an API inside the container that we can call. So I'm going to jump over here, just going to grab all of this here, jump back to our terminal, and then I will go ahead and run this. Now it's actually running this API locally, and it's actually giving you the URL that you can use to run this. So next up, what we're going to do is we're going to jump into Postman. Postman is an application that allows us to call APIs and test them out as if we were running these from make.com. I'm going to go up here to new, and I'm just going to go to HTTP call, and I'm going to change that request here from a GET to a POST. And then for the URL, we can jump back to our terminal here, and we're just going to copy exactly where it's listening from. Can take that, copy, take that back to Postman. And then the only thing that we're going to add here is the URL that we are using is transcribe media. Then we're going to jump over here to the headers, and we are going to write in x-API key. You want to make sure that that is checked. And remember, when we ran this, we set the API key to test123. So I'm going to go ahead and add that value here, test123. Now I'm going to jump over to the body. I'm going to set this to raw. We need to send it the information, the actual media URL to transcribe. So I'm going to create the curly braces. I'm going to type media URL colon, and now I'm going to pass in a Google Drive file link. And if you're using a Google Drive link, you do need to make sure that you're using this exact format for the file, and it also needs to be shared publicly. So even if I go to an incognito mode, you'll notice that this link still works, which is what you have to make sure that your link works as well so that it can actually be downloaded. So if you had your own video file that you wanted to test with, you just have to go into Google Drive and share it, get a share link by changing the access to anyone with the link. And then you could copy that link into your browser. And now you do need to get access to this ID here, and you need to put it into this specific format that I'm using here. Notice that this format here in this URL is not exactly the same. So when we pass the link as something that's downloadable, we need to make sure we use this format. I just simply insert that ID into this section here after the equal sign instead of using this URL directly here. I take this ID and copy that ID into this G Drive format. So this is the body we need to send to our API call. And if we jump back here to the original prompt, again, you're going to see that API key, which we set in this variable right here, where we set the environment variable. That's what the -E does. And you'll also know that when we constructed the API, we had that x-API key, which we are sending in the header right here, x-API key, and that value that we set right here when we ran the test. And you can see here that we are taking one parameter in the JSON body, the media URL. That is the URL to the media file. And if we jump to the body again here, that's exactly what you see us doing here. So we have everything ready to go. We changed it from GET to POST. We have the HTTP call that was given to us right here, listening at this address here. And again, we added the transcribe media endpoint, which is what we added here to describe this specific function. And now we have everything that we need. We should be able to go ahead and just send this request. Let's go ahead and send it and see what happens. We can see here that it's actually running. There was some sort of warning here. I'm not sure if that caused any issue on the back end. Looks like we did get an error here related to FFmpeg. I'm not sure why we're actually doing anything with FFmpeg. So in this case, we really have two potential errors. We have this one here, and then we also have this potential warning here. And so all you really need to do is take this. I'm going to take this warning, and I'm going to go back to Claude, and I'm going to say, I got this warning in the console, and then I'm going to put it in quotes. And I also got this error in Postman when sending the request to the API. And then I'm going to copy this error from Postman. And what I found is that Claude is just amazing at actually fixing those. So I'm going to put those two things in there and just send it back, and let's see what it comes back with. So apologize, it found both issues. So now what it's doing is it's giving us a replacement. So it found that there's an issue with it's missing a library we need, and it's going to fix this other issue. So all you really have to do is just feed it the errors that you're having, and it'll fix it. So now we need to update the Docker file. So I'm going to copy it, go back to the Docker file. Going to add that in. Make sure you save it. Come back to Claude. I'm going to grab the new code for the Python script. We're going to go to the app.py, select all, and copy in the new code. Let's see, did it give us anything else? That's all that we needed. Because it also asked for FFmpeg, I'm going to ask if it needs changes to the requirements. So I basically just asked the question, hey, since we made some changes, do we need to change the requirements.txt? It said we didn't, but it did suggest that we add these new specific versions to our file. So I'm going to do that. I'm going to go ahead and save everything, save each file that we changed. And now all we need to do is I'm going to exit out of Docker container we're running. I hit Control C. Now I'm going to go ahead and rebuild the Docker image based off of our new changes. Once that finishes, you can go ahead and rerun the container again. If you're new to the terminal, if you hit the up and down arrows, you can go back and forth between previous commands. In this case, I'm going to run the run command again. Now I'm going to jump back to Postman, and I'm just going to run the same execution again. If I jump back to the terminal, it's giving us a different warning, but this one shouldn't cause any issues. It's going to take a bit of time to download this file here and transcribe it. Now again here, what we are doing is we are calling our own API. We created that API and we deployed it, and now it's running here locally on our computer. And we're calling the API that's running locally on our computer. And now here we have the response. So here is the transcription from the video that I sent. And you're seeing here that it's in a JSON file with a response and then the text. And if we jump back to our Docker file, remember, if it was a success, we asked the API to return with an HTTP code 200 with the JSON string containing response and the transcript. So with just that, we've built out our API, we have it running locally, and we've tested it. Now all we need to do is to compile a version and upload it to a place like DigitalOcean, where we can run this API in a public space where we can run it from anywhere, and we have a URL that we can call, and we can actually call this from make.com, do our transcriptions using our own API service. If you're enjoying this video, make sure to like and subscribe to the channel. It tells me what type of content you want more of. All right, so now, like I said, we need to deploy this out to the internet so that we have our own API server that is existing, that we can call from make.com and get a response back from that service. What we just did was we built this server, but we built it on our local computer. So maybe if you built this out on a laptop, we built this whole API in our own server. So this is not going to work for trying to build out an automation in something like make.com. Make.com is not going to be able to call our laptop and get a response. So just like all APIs that we use, like OpenAPI, they've got that server out there that we can call. And so that's what we need to build now. And that's what we're going to use DigitalOcean for. So DigitalOcean is a platform where we can deploy our own apps, and they can be Docker apps, just like we built here in our text editor. And what we can do is we can log into the DigitalOcean platform, and we can go to their app platform, and then we can go to create an app. And this will allow us to launch our own personal server with a Docker image that we create and upload. But the issue now is that that current Docker image that we have was built locally on our computer, and we were testing it locally on our computer. So now we need to find a way to upload it to a place that DigitalOcean can use and download, and then finally deploy that server. So to make that happen, I'm going to use a service called Docker Hub. So you'll need to create a new account. You can go to hub.docker.com, and then you can go ahead and sign up and create an account. I've already got one, so I'm going to sign in. Now I already have a couple of repositories here, but I'm going to go ahead and create a new one. I'm going to name this repository the same that I used right here when I built the image on my computer, Docker API build. So I'm going to come right here to the repository name, Docker API -build, and then go ahead and make sure to leave it public and go ahead and create that new repository. You should have something that looks very similar to this. Now all we need to do is to build this Docker image and push it to this new repository that we built so that we can then deploy it from here in our DigitalOcean account. So obviously you will need to create a DigitalOcean account as well to actually make this deployment. So now I'm going to come back to my terminal, and I'm going to go ahead and select Control C, which will terminate the test run that we were doing with our image. And now the next thing we need to do is we need to rebuild the image for a different computer. When we built this image previously with this command right here, it was building this image to run locally on your computer. Now I happen to run an Apple computer which doesn't use an Intel processor. So if I were to try to deploy the image that I built on my Mac, it would not work when we try to deploy it to DigitalOcean, which is using Intel-based servers. I'm going to go ahead and delete the previous command that we used so I can enter in a new one. So now from here, I'm going to cut and paste a new command, which is going to build this Docker image to the platform that DigitalOcean uses, which is Linux/AMD64. And then I'm going to add these other commands here to build it out. The only thing I need to change here is the naming. I'm going to change this to Docker API build, which is what we were using previously, Docker API build. And you want to make sure that you change your name here to whatever your name is on the Docker Hub. So in Docker Hub, you can see that my username is Stephen G. Pope. And so right here, I'm using Stephen G. Pope. So if yours is something other than that, you would want to use whatever your name is. And then you want to make sure to rename the Docker image to what we've been using here, Docker API build. And then I'm using the :v1 for version 1, which is a tag, which is simply telling Docker Hub which version of our image we want to upload to. And then I'm using this little dot here to signify that we are building whatever's in this current directory here. So the command is docker build x build, and then the platform. Make sure you just copy everything exactly as is, including the double dashes, --load -t, your username on Docker Hub, and then the name of the image that we've been using. And then again, this time instead of Mac, I'm using v1, and then dot for this current directory. I'll go ahead and build by hitting enter. So again, it's going through that same build process that we went through before, except it's building it for a different platform. If we tried to run this image locally like we did before, it will fail. And then once it has finished building that new image, then you just have to push that image up to Docker Hub. So I'm going to copy this command here. Now, the only thing I need to change is the image name. This is a previous image that I was using. So again, I'm going to use the one that we've been using over and over again, which is this Docker API build. Again, remember, in your command, you're going to replace my name with whatever name you are using on Docker Hub. So now I'm going to type Docker API build. And again, I'm keeping that version 1 here. That's going to be important in just a moment. Now I'm going to go ahead and hit enter, and this should push it up to the new repository that I created right here. We'll go ahead and click enter. Now it's pushing up that image to this remote repository on Docker Hub. It is going to take some time for that to upload. Sometimes the images can be quite large. And once it's done, it's going to leave you back here. And then if you come back to Docker Hub and you do a refresh, it should show that you have finished uploading that image to your new repository. And now that we have this uploaded, we can jump back over to the DigitalOcean platform. I'll just start again from scratch. We'll go back to apps. I'm going to go to the app platform. You don't need any of these other things here. You will need a DigitalOcean account, so go ahead and create that. We're going to go ahead and create an app. We're going to use Docker Hub as our source for the repository name. You can come back to your repository and you can simply cut and paste this right here, Stephen G. Pope at Docker API build. Of course, yours is going to be slightly different. You can drop in that repository here. For the image tag, you're going to go ahead and use v1. If you remember when we uploaded the image, we had the image name and this little tag here, v1. Separated by that colon. So that's what we have here, the repository and the tag. We don't need to pass any credentials. I'm going to go ahead and click next. Now here's where you're going to select which type of server that you're using. I'm going to go ahead here and edit this. Now this server is a $12 a month server. I'm going to go ahead and use this one. I've had fewer issues. You might be able to use a smaller one. You will want to reduce the number of containers that you're using. Go ahead and move that down to 1. This basically allows you to run multiple servers of whichever size you pick. So again, you could pick a smaller server. You could pick the $5 or the $10 a month server. I'm going to go ahead and use the 12. I just have better responses and performance with that. But you can see here is if we can launch one server that's $12 a month and we can replace all sorts of different APIs within that cost, it's going to be a real easy way to save a lot of money. Now, in this case, we only replaced one API, which was the ability to transcribe media. But in our project, we're going to continue to add additional services to reduce all of the different APIs that we need to use. So from here, I'm going to go ahead with the $12 server. I'm going to do one container. I'll click save. Then we can come back and then we can move to the environment variables. Here, you're going to want to set a global variable edit. Here, you're going to want to put API key. And then again, you can put test 1, 2, 3. And then you can go ahead and click save. This is putting in our API key into the server we're about to build. Now we can go to next, and then here's our information. We can go ahead and click next. You can review everything before it goes out, and it's going to give you the estimated price. Now this price is if you let this server run for the entire month. If you build it and then destroy it a few hours later, you'll pay a small fraction of what this charge is. And then I'll go ahead and create the resource. So now what is happening here is that at this moment, DigitalOcean is creating our own little server, and it's taking that Docker file that we created and it's dropping that inside of that server, and it's setting everything else up for us. It's going to give us a URL that we can call, and then we'll be able to call this API and get a response from it once that build is finished. And it's taking the Docker image from Docker Hub, which is where we just uploaded that new image to. So you'll notice that it's building here. You can actually look at the logs as it's building it. If there's any errors, this is where you will see them. So now you're seeing some of the same stuff that we saw when we were testing locally. Remember, when we were testing locally, it was giving us that same information. So now what we see here is that it's now running on this remote server. And now what we can do is we can use Postman to actually test against our remote server instead of our local server. So if you notice here, we have this URL here, which is the URL for the server we just launched. So I can come here and I can copy that link address. I can come back to Postman, and instead of sending this API request to our local server, which is no longer running, I'm just going to simply replace this section here with our new URL that was given to us from DigitalOcean. Make sure you don't add in 2 slashes there. I'm going to remove one of those. And now I should be able to use this same API call to call our DigitalOcean server instead of our local server that we had running in our terminal here. So I'll go ahead and come back to Postman, and I will send this request now to our new server, come back to DigitalOcean, and you can always see the current activity and the runtime log. So now it's showing you that same issue that we had here locally, which is not really an error that's going to cause any issues. So if we come back to Postman, still running, but now we've had that response. So now we actually have our API working on our own DigitalOcean platform. And so now if we wanted to test this from make.com, it would be pretty easy to do. I'll jump over to make. I'm going to create a new scenario. In this case, I'm just simply going to use the HTTP module, and we will make a request. Here, I'm going to post the URL that we will be using for our API. And again, remember that came from this link right here. I'll come back to the URL, copy that in, and then again, I'm going to type transcribe media. That was the endpoint that we added for this new action. This method needs to be changed to a post. And for the header, I'm going to type x-API key, and then we'll put test 1, 2, 3. We don't need any other headers or query string. I'm going to simply come down to the body type. We're going to type raw. For content type, we're going to use JSON application JSON. And for the request content, I'll just come over to Postman. I'm going to copy this and then paste that into the request content. I'll go ahead and parse response yes. I'll go ahead and click OK. And now if I run this module only, it's going to be calling that same API just as we did from Postman, except now we're calling it from make.com. It's going to execute that API call against our DigitalOcean server that is using our Docker file and the API that we built from scratch. And now that ran successfully. We're getting a status code 200. If we look at the data here, we'll see the response. And we've had clients that have tripled the amount of content they were producing each day with a smaller team. And there we have that transcription that we were able to pull from the media file that we sent in the API call. And again, if you want access to the prompts to build your own APIs, or if you just want access to my pre-built Docker images, make sure to jump into the No Code Architects community, where you can also get tech support from me and my team. You can also join the live calls. We have one almost every single day. Inside the community, you can get personalized help from me to get all of this stuff set up. Either way, I hope you enjoyed this video, and I'll see you on the next one.